You're standing in the scorching Egyptian sun, your back already aching, and it's only been 3 hours. Your hands are calloused, your feet are blistered, and you're pretty sure you've got sand in places sand should never be. You look up at the massive limestone block in front of you, 2.5 tons of pure, why did I sign up for this? And you realize something absolutely wild. You're about to help build one of the most iconic structures in human history. No, you don't have cranes. No, you don't have wheels. Hell, you don't even have a decent pair of shoes. But you know what you do have? 4,500 years of spite to prove to future internet conspiracy theorists that yes, humans absolutely could build this thing without alien intervention. Welcome to 2550 BCE, where the Great Pyramid of Giza is about to become humanity's most impressive hold my beer moment. Now, before we get into the absolutely insane logistics of how ancient Egyptians moved 2.3 million stone blocks, weighing a combined 6 million tons, let's address the elephant in the room. Or should I say, the alien in the desert. You've seen the documentaries, you've heard the theories. Ancient astronauts, lost civilizations with advanced technology. It's impossible for humans to have built this. And look, I get it. When you're standing in front of a structure so precisely aligned to true north that it's only off by 3/60 of a single degree, built with stones so perfectly fitted that you can't slide a piece of paper between them, your brain kind of short circuits. It feels impossible. But here's the thing that always gets me about these conspiracy theories. They're actually kind of insulting. Not to aliens, I'm sure they're lovely folks if they exist, but to the thousands of skilled Egyptian workers, engineers, mathematicians, and laborers who spent decades of their lives creating something so magnificent that we're still talking about it 4,500 years later. These weren't primitive people scratching their heads at big rocks. These were sophisticated engineers who had been perfecting stone construction for centuries, before the Great Pyramid was even a twinkle in Khufu's eye. So buckle up, because we're about to dive into one of the most fascinating engineering projects in human history. And I promise you, the real story is so much more interesting than aliens did it. Part 1, the prep work, or how to plan the world's most ambitious construction project. Let's rewind a bit. It's approximately 2580 BCE, and Pharaoh Khufu has just ascended to the throne. He's got big sandals to fill. His father Sneferu was basically the Elon Musk of pyramid building, having constructed not one, not two, but 3 massive pyramids during his reign. Talk about an overachiever dad. So naturally, Khufu looks at his father's accomplishments and thinks, yeah, but could he go bigger? Spoiler alert, he could not. Khufu's pyramid would become the tallest man-made structure on Earth, a record it would hold for an absolutely bonkers 3,800 years. For context, that's longer than the entire span of time, from the Roman Empire to now. I'll let that sink in. But before a single stone gets moved, there's an absolutely mind-boggling amount of planning that needs to happen. And this is where ancient Egyptian engineering really starts to shine, because these people were meticulous. First order of business, picking the location. And this isn't just about finding a nice spot with a good view. The pyramid needed to be on the west bank of the Nile. The west was associated with the dead and the afterlife, because that's where the sun set. But it also needed to be close enough to the Nile for transport, on bedrock solid enough to support millions of tons of stone, and positioned in a way that would allow for the precise astronomical alignments that were crucial to Egyptian religious beliefs. They settled on the Giza Plateau, a massive limestone bedrock formation about 40 meters above the Nile floodplain. Perfect foundation, check. Close to the Nile for transport, check. Positioned to align with important stars and the cardinal directions, check, check, check. Now here's where it gets really cool. The Egyptians needed to create a perfectly level base for the pyramid. And we're not talking pretty level. We're talking level to within 2.1 centimeters across a base that's 230 meters long. That's an error margin of less than 0.01%. On a structure covering 13 acres, with Bronze Age technology, How did they do it? Water. Brilliant, simple, elegant water. They carved a network of trenches into the bedrock in a grid pattern, then flooded them. Water, as you might know, from that time, you tried to convince yourself your floor was level. Always finds its own level due to gravity. By marking the water line around the entire perimeter and then carving the bedrock down to that line, they created a foundation so level it would make modern construction workers weep with envy. But wait, there's more. They also needed to align the pyramid precisely with the cardinal directions, north, south, east, and west. And before you ask, no, they didn't have compasses. Compasses wouldn't be invented in China for another 2,000 years or so. Instead, they used the stars. Specifically, they used a technique called the Indian circle method. Here's how it works, and it's genuinely beautiful in its simplicity. You take a straight pole and stick it in the ground. Throughout the day, you mark where the shadow falls at regular intervals, creating a curved line. The shortest shadow point, that's exactly north. But Egyptian astronomers took it even further, using circumpolar stars, stars that never set below the horizon, to achieve even greater precision. The result, the Great Pyramid's alignment to true north, is accurate to about 3/60 of a single degree. That's more accurate than the Paris Observatory, which was built in the 17th century CE Bronze Age. Astronomers just casually flexing on the Age of Enlightenment. Now, while all this prep work is happening, there's another absolutely crucial element that needs to be sorted out: the workforce. And this is where we need to bust another major myth that's been perpetuated for literally thousands of years. The pyramids were not built by slaves. I know. Every movie, every TV show, every dramatic recreation has shown us lines of enslaved people being whipped as they drag stones across the desert. It's a powerful image, and it's been repeated so many times that it feels like it must be true. There's just one tiny problem. It's completely, totally, historically inaccurate. Here's what we actually know from archaeological evidence. The pyramids were built by paid workers. We found their settlements, their cemeteries, their payroll receipts, yes, really, and even their graffiti. These weren't enslaved people. They were skilled laborers, seasonal workers, and patriotic citizens participating in a national project. The evidence for this is actually pretty overwhelming. In the 1990s, archaeologist Mark Lenner and his team discovered a massive workers' settlement near the pyramids that could house between 10,000 to 20,000 people. This wasn't a slave camp. It was a purpose-built city with bakeries, breweries, copper workshops, fish processing facilities, and even what appears to be a medical clinic. We found workers' graffiti on the stones themselves, with team names like Friends of Khufu and Drunkards of Menkaure. Not exactly what you'd expect from an enslaved workforce. There's a certain amount of pride and personality in those inscriptions that speaks to people who saw themselves as part of something important. And here's the kicker. We found the workers' cemetery. When archaeologists examined the remains, they found evidence of medical care, including healed broken bones that had been set properly and injuries that had been treated. Enslaved people don't typically get top-notch medical care. These workers were valued, and when they were injured on the job, someone took the time and resources to heal them properly. But perhaps the most compelling evidence comes from the logistics themselves. The ancient Egyptians had a system called the corvée, which was essentially a labor tax. During the inundation season, when the Nile flooded for about 3 months every year and farming was impossible, farmers would come to work on state projects. They'd be fed, housed, and this would count as paying their taxes to the state. It was a brilliant system that took advantage of seasonal downtime in the agricultural cycle. For the Great Pyramid, estimates suggest that the permanent workforce was probably around 5,000 skilled workers, quarrymen, stone haulers, surveyors, engineers, and craftsmen. During the inundation season, this would swell to perhaps 20,000 to 30,000 people with the addition of temporary workers. And they were fed, like seriously well fed. Analysis of animal bones found at the workers' settlement shows that these people were eating beef, mutton, and fish. We're talking about hundreds of pounds of meat being consumed daily. One study estimated that the workers were consuming about 4,000 pounds of meat every day, plus bread and beer. This wasn't subsistence rations. This was fuel for hard workers, and it was provided by the state. The beer, by the way, wasn't just for fun, though I'm sure that was a bonus. Ancient Egyptian beer was thick, nutritious, and relatively low in alcohol, more like liquid bread than modern beer. It was a staple part of the diet, and a safe way to consume calories and nutrients when clean water might be questionable. Part 2, the stones, or how to move really, really heavy things without wheels. All right, so you've got your level foundation, your precise alignment, and your workforce of thousands. Now comes the fun part, actually building this thing. Let's start with the most basic question. Where did all these stones come from? The core of the pyramid, the bulk of those 2.3 million blocks, was made from local limestone quarried right there on the Giza Plateau. This was relatively soft limestone, easier to quarry and shape than you might think, but the exterior casing stones, those were special. Those came from Tura, a limestone quarry about 13 kilometers away on the other side of the Nile. Tura limestone was finer, whiter, and could be polished to a brilliant shine. When the pyramid was complete, it would have gleamed in the sunlight like a massive beacon. And then there were the granite blocks used in the king's chamber and the relieving chambers above it. Granite is hard, like really hard. And the nearest granite quarry was at Aswan, about 800 kilometers south. The Egyptians that somehow transported granite blocks weighing up to 80 tons down the Nile, and then incorporated them into the pyramid's internal structure with such precision that modern engineers are still impressed. But let's focus on the local limestone for now, because this is where the real volume of work happened. Quarrying limestone in ancient Egypt was a surprisingly sophisticated process. These weren't people just whacking at rocks with copper chisels and hoping for the best. They had a systematic approach that was refined over centuries. First, they'd identify the natural bedding planes in the limestone, the layers where the rock naturally wanted to separate. Working with the stone's natural properties rather than against them was key. They'd then cut channels around the block they wanted to extract, using copper tools, wooden wedges, and a technique called fire setting, where applicable. Here's how fire setting worked. You'd build a fire against the rock face to heat it up significantly. Then you'd throw cold water on it. The rapid temperature change would cause the rock to crack along natural fissures. It's not as controlled as modern explosives, but it's surprisingly effective for creating initial breaks in the stone. For the actual extraction, they'd cut trenches around the desired block using copper tools. And yes, copper is softer than limestone, so you might be wondering how that works. The secret? Sand, copper tools, plus quartz sand equals an effective abrasive that could cut through limestone. The copper tool acts as a guide, while the sand does the actual cutting. Clever, right? Once the channels were cut, they'd use wooden wedges. They'd hammer these wedges into the cuts. And here's the really cool part. They'd then soak the wedges with water. As the wood absorbed the water, it would expand with incredible force, enough to split the stone along the desired line. Slow, controlled, and effective, but cutting the blocks out of the quarry was just the beginning. Now you had to move them. And this is where things get really interesting, because we're talking about blocks that typically weighed 2.5 tons each, with some weighing up to 80 tons. No wheels, no pulleys, no iron tools. How? The answer, like so many Egyptian engineering solutions, is actually simpler and more brilliant than you might expect: sledges and water. Here's what we know from archaeological evidence and experimental archaeology. The Egyptians would load stones onto wooden sledges, basically large sleds. Then they drag these sledges across surfaces that had been wetted, and that last part is crucial. For years, this seemed almost too simple. How could wetting the sand possibly make dragging multi-ton blocks easier? Wouldn't wet sand just make things worse? Then, in 2014, a team of physicists from the University of Amsterdam conducted experiments that validated what the Egyptians had figured out 4,500 years ago through trial and error. When you add the right amount of water to sand, not too much, not too little, it reduces the friction between the sledge and the sand by up to 50%. Here's the physics. Dry sand piles up in front of a sledge, creating resistance. Wet sand, on the other hand, has capillary bridges, tiny water droplets that create bonds between sand grains, making it more cohesive and less likely to pile up. The sledge glides over it much more easily. Too much water and you just create mud, which is also terrible, but get the ratio right, and moving massive blocks becomes dramatically easier. And we're not just speculating about this. There's direct evidence. In the tomb of Jehuti-Hotep, there's a famous wall painting showing 172 men pulling a massive statue on a sledge. And right there in the painting, you can see a guy standing at the front of the sledge, pouring water onto the sand ahead of it. The Egyptians literally left us an instruction manual, and it took us thousands of years and modern physics to understand why it worked. But sledges and wet sand only get you so far, literally. They work great for moving stones across relatively flat ground, but the pyramid isn't flat. It gets taller and taller, and those blocks need to go uti. This is where we get into one of the biggest debates in Egyptology. How did they lift the stones? There are several theories, and honestly, they probably used a combination of techniques. The most widely accepted idea involves ramps. Not just one ramp, but potentially several different types, used at different stages of construction. The simplest version is a straight ramp that gets longer and longer as the pyramid gets taller. The problem? By the time you're near the top of the pyramid, you'd need a ramp over a mile long to maintain a reasonable slope. That's a lot of material, and there's not really evidence of a structure that massive. More likely, they used a combination of approaches. Exterior ramps for the lower levels. These could be straight or spiraling around the pyramid. There's actually evidence of ramp remnants at some pyramid sites. These would work well when the pyramid is still relatively low. Interior ramps for the upper levels. This is a theory proposed by French architect Jean-Pierre Houdin, and it's honestly brilliant. The idea is that there's a spiral ramp inside the pyramid, built as part of its structure. This would explain how they could lift stones all the way to the top without needing increasingly impractical external ramps. There's some evidence supporting this from microgravimetry scans that show less dense areas inside the pyramid that could be ramps. Lever systems for the final placement. Once you got a stone close to where it needed to be, you could use simple machines, levers, and fulcrums to make fine adjustments. Experiments have shown that a team of workers using wooden levers could lift and position stones, weighing several tons with surprising precision. The brilliant thing about all these methods is that they use simple machines, ramps, inclined planes, levers, and potentially simple counterweights. These are tools and concepts that the Egyptians absolutely had access to and understood. No advanced technology required, just a deep understanding of mechanical advantage and a whole lot of organized labor. Now let's talk about one of the most mind-blowing aspects of pyramid construction, the precision. The base of the Great Pyramid is a square, and the accuracy of that square is kind of absurd. The four sides vary in length by no more than 4.4 centimeters, on sides that are each about 230 meters long. That's an error of less than 0.02%. The casing stones, those fine Tura limestone blocks that formed the outer surface, were fitted together so precisely that you couldn't slip a piece of paper between them. No mortar was used in most of the joints. The stones were just cut and placed with such accuracy that they held themselves in place through sheer precision and the massive weight pressing down from above. How did they achieve this level of accuracy with copper tools and no modern measuring instruments? The answer involves a combination of techniques that showcase Egyptian mathematical and engineering sophistication. Cubit rods. These were standardized measuring tools, typically about 52.4 centimeters long, divided into smaller units. Egyptian builders carried these to ensure consistency in measurements across the entire project. We've found actual examples of these rods, often made of wood or stone, with incredibly precise markings, set squares and plumb bobs, for ensuring right angles and vertical alignment. These simple tools, when used carefully, can achieve remarkable accuracy. Strings and stakes, for laying out large-scale measurements and ensuring straight lines over long distances. Trial and error plus experience. This wasn't the first pyramid. By the time of Khufu's Great Pyramid, Egyptian builders had been constructing increasingly sophisticated stone structures for generations. They'd learned from their mistakes, and there, where mistakes, see the bent pyramid, and refined their techniques over time. But here's something that really gets me. The stones weren't just cut to fit their specific spot in the pyramid. They were also numbered and marked with team names and instructions. We've found quarry marks on many of the internal stones that indicate which team cut them, which gang was responsible for moving them, and sometimes even where they were meant to go in the structure. This level of organization is what really separates the pyramid builders from random people moving rocks. This was project management on a scale that wouldn't be seen again for thousands of years. Someone had to coordinate dozens of teams across multiple quarries, manage the transport of millions of blocks, organize the feeding and housing of tens of thousands of workers, and ensure that everything came together in the right order and the right place. The logistics alone are enough to make any modern project manager break out in a cold sweat. Here's the word count for part 1, approximately 3,900 words. Continuing with part 2 now. Part 3, the engineering marvels, or these people were showing off. So we've covered the basics of how they cut, moved, and lifted the stones. But here's where the Egyptian engineers really started flexing the internal structure of the pyramid. Because here's the thing, the Great Pyramid isn't just a big pile of rocks. It's got chambers, passageways, shafts, and structural features that are so sophisticated they're still revealing secrets to modern researchers. Let's start with the Grand Gallery. If you've ever seen pictures of the interior of the Great Pyramid, you've probably seen this, an ascending corbelled passage that rises at a 26-degree angle, about 8.6 meters tall and 47 meters long. The walls are made of massive limestone blocks, and here's the cool part. They're corbelled, meaning each successive layer juts out slightly more than the one below it, creating a ceiling that gets narrower as it goes up. Why corbelling instead of a flat ceiling? Because a flat ceiling would need to support the weight of all the stone above it in tension. Basically, it would be trying to pull apart. Stone is terrible in tension. It wants to crack and fail. But corbelling transfers the weight down through the sides in compression, which stone is excellent at handling. It's the same principle behind arches, and it's used in structures all over the world. But the Grand Gallery isn't just showing off fancy architectural techniques. It's likely that it served a practical purpose during construction. Many Egyptologists believe it was used to store the massive granite plugs that would seal the pyramid after the pharaoh was entombed. These plugs would have been stored on the inclined floor of the gallery, held in place by temporary blocks, then released after the burial to slide down and block the ascending passage. Tomb security through physics. Then there's the King's Chamber. This is where things get really impressive. The King's Chamber is made entirely of granite blocks. Remember, those came from Aswan, 800 kilometers away. The chamber measures about 10.5 meters east-west by 5.2 meters north-south, with a height of 5.8 meters, and it contains a granite sarcophagus that's too large to have fit through the passages leading to the chamber. Think about that for a second. The sarcophagus had to have been placed in the chamber as the pyramid was being built around it. You can't move it in or out through any of the passages. This means the entire construction sequence had to be planned out in advance, with the sarcophagus being positioned at exactly the right moment in the building process. Talk about advanced planning. But the really mind-blowing feature of the King's Chamber is what's above it, the relieving chambers. Above the King's Chamber are 5 separate compartments, one on top of the other, with massive granite. Beams forming the ceilings. The topmost compartment has a pointed roof made of massive limestone blocks, angled like a gable. The total height of this system is about 17 meters. The purpose? To relieve the immense weight of the pyramid above the king's chamber. We're talking about roughly 2 million tons of stone pressing down. Without these relieving chambers, the ceiling of the king's chamber would have cracked and collapsed under the pressure. Instead, the weight is distributed through the granite beams and into the pyramid structure on either side of the chamber. And this is 4,500-year-old engineering that's still working perfectly. When you consider that the granite beams in these relieving chambers weigh up to 80 tons each, and they're positioned with precision about 60 meters above ground level, inside a growing pyramid, the logistics are absolutely staggering. Let's talk about those mysterious shafts for a second, because they're weird and fascinating, and we're still not entirely sure what they were for. From both the king's chamber and the queen's chamber, there are narrow shafts that run through the pyramid at specific angles. The shafts from the king's chamber reach all the way to the exterior of the pyramid. The shafts from the queen's chamber don't. They stop before reaching the outside, and weren't even discovered until the 19th century, when an engineer noticed cracks in the walls and decided to investigate. These shafts are only about 20 centimeters square, way too small for a person to fit through. So what were they for? Theory number 1, ventilation. Maybe they were meant to provide air circulation for workers inside the pyramid during construction. Problem: the queen's chamber shafts don't go all the way through, so they wouldn't actually ventilate anything. Theory number 2, star shafts. The angles of the shafts from the king's chamber align with important stars in ancient Egyptian cosmology. The northern shaft points to where the circumpolar stars, important in the Egyptian afterlife beliefs, would have been visible from inside the pyramid, while the southern shaft aligns with Orion's belt, associated with Osiris. Maybe these were meant as passageways for the pharaoh's soul to ascend to the stars. Theory number 3, religious symbolism we don't fully understand. Maybe there's some aspect of Egyptian religious belief that we're missing that would make the purpose of these shafts obvious. Honestly, we don't know for sure, and that's actually kind of cool. After 4,500 years and countless studies, the pyramids still have secrets. In 2002, a robot camera was sent up one of the queen's chamber shafts. It traveled 65 meters and then encountered a stone door with copper handles. The excitement was huge. What was behind it? In a live broadcast watched by millions, they drilled through the door and sent the camera through. Behind it, another stone block, about 20 centimeters further in. The pyramid was trolling us. Respect. Part 4, the timeline, or how to build a wonder of the world in 20 years. Now let's talk about possibly the most impressive aspect of the Great Pyramid, the timeline. According to Herodotus, writing about 2,000 years after the pyramid was built. So take this with a grain of salt. The Great Pyramid took 20 years to construct. Modern Egyptologists actually think this is probably pretty close to accurate. 20 years for 2.3 million stone blocks. Let's do some math that'll hurt your brain. If they worked year-round, every single day, they didn't, but let's assume, that's 7,300 days. To place 2.3 million blocks in 7,300 days, you'd need to set a block every, checks calculator, roughly every 3 to 4 minutes, working 24 hours a day. Obviously, they weren't working 24/7. A more realistic estimate, accounting for the inundation season when most labor was available, reasonable working hours, and the need for planning and logistics, suggests they were probably placing blocks at a rate of 1 every few minutes during peak construction periods. That's still absolutely bonkers. This wasn't a slow, methodical process. This was a highly organized, incredibly efficient operation, running at a pace that would impress modern construction companies. And here's what makes it even more impressive. They got faster as they went. Think about it. Early on, they were still figuring things out, setting up systems, getting teams coordinated. By year 5 or 10, everyone knew their jobs. The quarry teams had their rhythms down. The transport teams had optimized their routes. The placement crews could work with their eyes closed. They developed muscle memory, efficient handoff procedures, and probably a ton of tricks and shortcuts that made the work faster. It's the same principle as any modern manufacturing process. The more you do something, the more efficient you become. Except instead of assembling cars, they were assembling a mountain. The construction sequence probably went something like this. Years 1 to 2. Site preparation, leveling the foundation, setting up worker facilities, establishing quarries, and beginning the lower courses. This is where you're making all your mistakes and learning what works. Years 3 to 10. Rapid construction of the bulk of the pyramid. Teams are working like well-oiled machines. The majority of the 2.3 million blocks are placed during this period. This is peak efficiency time. Years 11 to 18. Upper courses and internal chambers. Things slow down a bit here because you're working at height. The blocks need to be lifted further, and you're doing more intricate internal work like the chambers and passages. Years 19 to 20. Casing stones and final finishing. The entire exterior would have been covered in gleaming white Tura limestone, precisely cut and polished. The capstone, pyramidion, would have been placed, possibly covered in gold or electrum to catch the sun. By the end, what stood on the Giza Plateau was a structure 146.6 meters tall. That's about 481 feet, covering 13 acres, containing approximately 2.3 million stone blocks, with a total mass of about 6 million tons. It would remain the tallest man-made structure in the world until Lincoln Cathedral spire was completed in 1311 CE. Let me repeat that. It held the record for almost 3,800 years. The Empire State Building, the Eiffel Tower, medieval cathedrals, none of them beat the height record of a structure built in the Bronze Age with copper tools and wooden sledges. Part 5. The workforce culture, or why team spirit actually matters when building mountains. Let's circle back to the people for a moment, because understanding the workforce culture is absolutely essential to understanding how this project succeeded. Remember those graffiti inscriptions I mentioned earlier? The team names. This wasn't just workers killing time. This was genuine pride in their work. The crews were organized into competing teams with names like Friends of Khufu, Drunkards of Menkar, and my personal favorite, the Vigorous Gang. These teams competed with each other. There's evidence that they kept tallies of how many blocks they moved, how fast they worked, and they absolutely talked trash about rival teams. We've found inscriptions that are basically ancient Egyptian equivalents of Team A rules, Team B drools. This is brilliant psychology. When you're doing backbreaking labor in the desert sun, having a sense of camaraderie, competition, and purpose makes all the difference. These weren't just anonymous workers. They were members of Team Vigorous Gang, and they had a reputation to uphold. The organization was hierarchical, but not in the brutal way you might imagine. At the top, you had the architects and senior engineers, people like Hemiunu, who was Khufu's vizier and is believed to have been the architect of the Great Pyramid. Below them were skilled craftsmen, surveyors, stonemasons, carpenters. Then you had the semi-skilled workers, people who specialized in specific tasks like hauling or block placement. And at the base, you had the seasonal workers who came during the inundation. But here's the crucial part. Evidence suggests there was actual social mobility. Skilled workers could advance. Particularly talented individuals could move up in the hierarchy. Graffiti shows workers expressing pride, not just in their team, but in their personal achievements. This wasn't a system designed to crush people. It was designed to harness their abilities and, yes, their ambition. The workers lived in a purpose-built settlement that archaeologists call the Workers' City. This place had everything: dormitories for the laborers, nicer houses for skilled workers and supervisors, bakeries that could produce thousands of loaves daily, breweries, because beer was essential to the diet, copper workshops for tool maintenance and creation, and fish processing facilities. There was even what appears to be a medical facility. Analysis of skeletal remains shows that workers received medical treatment for injuries. We've found bones that were set after breaks, evidence of successful amputations, which is absolutely wild for Bronze Age medicine, and treatment for work-related injuries. One worker had a leg amputated, and not only did he survive the procedure, but he lived for many years afterward. Someone cared enough to save his life and support him after he could no longer do hard labor. The diet, as I mentioned before, was substantial. These workers were eating better than most ancient Egyptians. Meat several times a week, fish, bread, beer, and vegetables. The state was investing in keeping these workers healthy and strong because healthy workers are productive workers. There's also evidence of cultural activities. We found game boards suggesting workers had leisure time and ways to entertain themselves. There are religious shrines in the workers' settlement, indicating that spiritual life was part of the community. This wasn't a death camp. This was a functioning city, dedicated to a singular massive project. Part 6, the mathematics, or how Bronze Age. Egypt flexed on future civilizations. Now we need to talk about the math, because the mathematical precision of the Great Pyramid is frankly absurd. Let's start with the dimensions. The base of the pyramid is approximately 230.4 meters on each side. The ratio of the perimeter of the base to the height is 2 pi. This means that if you took the height of the pyramid and multiplied it by 2 pi, you'd get the perimeter of the base. Did the Egyptians know about pi? That's a fascinating question. They definitely understood the mathematical relationship between circles and their measurements, even if they didn't have the same notation we do. The Rhind Mathematical Papyrus, an ancient Egyptian mathematical text, shows they used an approximation of pi. They calculated it as approximately 3.16, which is pretty close to the actual value of 3.14159. Whether they intentionally built this ratio into the pyramid or whether it's a consequence of other design choices is debated. But either way, there it is, baked into a structure built 4,500 years ago. The angles are equally impressive. The pyramid rises at an angle of approximately 51 degrees, 50 minutes, 40 seconds. This isn't random. This angle has a specific mathematical property. If you draw a circle with radius equal to the height of the pyramid, the circumference of that circle equals the perimeter of the pyramid's base. Again, pi showing up in the design. But it gets weirder. The C-kid of the pyramid, that's the ancient Egyptian way of measuring slope. Basically, the ratio of horizontal run to vertical rise works out to a ratio that corresponds to the golden ratio, phi, approximately 1.618, when you do certain calculations with the pyramid's dimensions. Now, did the Egyptians know about the golden ratio? We don't have direct evidence that they did, but we have a lot of circumstantial evidence that they understood proportions and ratios that we now recognize as the golden ratio. It shows up in their art, their architecture, and yes, possibly in their pyramids. Some researchers argue these mathematical relationships are coincidental, or that we're reading too much into them, imposing our modern mathematical understanding onto ancient structures. And that's fair. We should be careful about assuming the ancients thought exactly like we do. But here's my take. These were sophisticated mathematical thinkers who had been working with geometry, ratios, and proportions for centuries. The mathematical relationships in the pyramid might not have been expressed the way we express them, with pi and phi and all our fancy notation. But the Egyptians understood these principles in their own way. They knew what worked, what created pleasing proportions, and what achieved structural integrity. The precision wasn't just in the overall design, it was in every detail. The casing stones were cut to tolerances that would be impressive even with modern tools. The internal passages maintain their angles with remarkable consistency. The chambers are positioned precisely where they need to be within the massive structure. Consider the descending passage. This starts at the entrance on the north face and descends at a 26-degree angle into the bedrock beneath the pyramid. It's about 105 meters long, and along its entire length deviates from perfectly straight by less than 6 millimeters. That's less than a quarter inch over 100 meters of tunnel cut through solid rock. How? Trial and error, experience, and sophisticated surveying techniques. They used plumb bobs, levels, measuring rods, and probably a lot of intermediate checkpoints to ensure they stayed on course. But the end result is precision that seems almost impossible for the technology available. Part 7. The casing stones. Or, when your pyramid was so shiny it could be seen from space. Let's talk about what the Great Pyramid originally looked like, because it was nothing like what you see today. Today, when you look at the Great Pyramid, you see a stepped structure of rough, yellowish-brown limestone blocks. It looks ancient, weathered, like exactly what you'd expect a 4,500-year-old building to look like. But that's not what it looked like when it was finished, not even close. When the Great Pyramid was completed, the entire exterior was covered in fine, white Tura limestone casing stones. These stones were cut with such precision that the entire pyramid's surface would have been smooth and flat. And these weren't just smooth, they were polished. Imagine a structure 146 meters tall, covering 13 acres, completely covered in brilliantly polished white limestone that reflected the Egyptian sun like a massive mirror. The pyramid would have gleamed, like a beacon visible for miles around. Some historians suggest it would have been visible from the mountains of Israel on a clear day, though that might be slight exaggeration. The capstone, the pyramidion at the very top, was probably covered in electrum, a gold-silver alloy, or possibly solid gold. When the sun hit the pyramid, the golden cap would have blazed, and the white sides would have reflected light in all directions. It must have been absolutely spectacular, awe-inspiring in a way that's hard to imagine now. So what happened to all those beautiful casing stones? Earthquakes and time claimed some of them, but the real culprit was human quarrying. In the centuries after the pyramid's construction, and particularly after the rise of Cairo as a major city, people needed building materials. And hey, look, there's a mountain of perfectly good cut limestone just sitting there on the Giza Plateau. The casing stones were systematically stripped away and used to build mosques, fortresses, and buildings throughout Cairo. A 14th century earthquake damaged many of the remaining casing stones, making them easier to remove, and by the 15th century, most of the fine white limestone was gone. There are still a few casing stones in place near the base of the pyramid. If you visit today and look carefully, you can see them. Smooth, precise, completely different from the rough core blocks. They're a hint of what the entire structure once looked like. In a way, the Great Pyramid was too successful. It was such a good source of quality pre-cut stone that it was essentially quarried for parts over the centuries. The irony is that the building materials for some of medieval Cairo's most beautiful buildings came from one of ancient Egypt's most beautiful buildings. Part 8, the other pyramids, or Khufu, wasn't the only show-off. We've been focusing on the Great Pyramid of Khufu, but we should talk about the fact that it's not alone on the Giza Plateau. There are two other major pyramids right there, Khafre's Pyramid and Menkaur's Pyramid. Khafre's pyramid is Khufu's son, and his pyramid is slightly smaller than his father's, 143.5 meters tall originally, compared to Khufu's 146.6 meters. But here's a sneaky thing. Khafre built his pyramid on slightly higher ground, so from certain angles, it actually looks taller than the Great Pyramid. Talk about finding a loophole in the don't upstage your dad rule. Khafre's pyramid still has some of its original casing stones at the top, giving us a glimpse of what these structures originally looked like. It's actually pretty useful for understanding the pyramids because you can see both the core blocks and the casing stones in the same structure. Menkaura's pyramid is significantly smaller, only about 65 meters tall, but it's still an impressive structure. What's interesting about Menkaura's pyramid is that it shows a different approach to casing stones. The lower courses were cased in red granite, which was much harder to work with than limestone, but also more durable and prestigious. The upper courses were done in white limestone, but the Giza pyramids weren't the first, and they weren't the last. They were the culmination of about a century of pyramid evolution. Let's rewind to the beginning of the Pyramid Age. It starts with the step Pyramid of Djoser at Saqqara, built around 2630 BCE. This is considered the first true pyramid, designed by the legendary architect Imhotep, who was later deified, because if you're going to be good at your job, you might as well become a god. It's essentially 6 mastabas, traditional Egyptian tomb structures, stacked on top of each other, getting progressively smaller. This was revolutionary. Before this, royal tombs were mastabas, rectangular structures with flat roofs. Imhotep looked at that and said, but what if we went up-y? After Djoser, there was a period of experimentation. The pyramid at Meidum started as a step pyramid and then was filled in to create smooth sides. It partially collapsed, possibly during construction, possibly later. Either way, lesson learned about structural engineering. Then came Sneferu, Khufu's father, and this dude was obsessed with pyramids. He built 3 of them. The bent pyramid. This one is hilarious in a learn from your mistakes kind of way. They started building at one angle, about 54 degrees, and partway through, they changed to a shallower angle, about 43 degrees, giving it a distinctive bent appearance. Why? Probably because they realized the original angle was too steep, and the pyramid was showing signs of stress and potential collapse. So they adjusted mid-construction. The result is weird-looking, but structurally sound, and it taught them valuable lessons about pyramid geometry. The Red Pyramid. Learning from the bent pyramid, Sneferu built another pyramid at the shallower angle from the ground up. This is the first successful smooth-sided pyramid, and it's called the Red Pyramid because of the reddish color of the limestone used in its construction. This was the trial run that proved the concept worked. The pyramid at Meidum, possibly. Some Egyptologists think Sneferu also completed or modified this pyramid, though it's debated. So by the time Khufu came to power, his father had already built the equivalent of a masterclass in pyramid construction. Khufu took all those lessons and said, cool, now let me make one bigger and more precise. And he absolutely did. After Khufu and his successors at Giza, pyramid construction continued for centuries, but they never again reached the sheer scale and precision of the Giza pyramids. Later pyramids were smaller, and many weren't built with the same quality of materials or craftsmanship. The Pyramid Age peaked at Giza. Part 9, the mystery tech, or things we still don't fully understand. Despite everything we've figured out about pyramid construction, there are still some techniques and tools we're not entirely sure about. Take the copper tools, for example. We know the Egyptians used copper chisels, saws, and drills. We've found them in archaeological contexts, but copper is soft. It's softer than many types of stone. So how did they cut granite, which is significantly harder than copper? The working theory is that they used copper tools in combination with abrasive materials, specifically quartz sand. The copper tool acts as a guide, while the quartz sand, being harder than both the copper and the stone, does the actual cutting. You'd keep adding wet sand to the cutting area, and the repeated motion of the copper tool through the sand would gradually grind through even hard granite. Experiments have shown this works, but it's slow. Cutting through granite this way is a process measured in hours per inch. But when you have thousands of workers and years to complete the project, slow isn't necessarily a deal breaker. But here are some things that still puzzle researchers. The precision of the drill holes. In some granite blocks, we find circular drill holes that are remarkably uniform and deep. The precision of these holes and the apparent speed at which they must have been drilled, based on the spiral grooves left in the stone, suggests a technique we haven't fully recreated. Some experimental archaeologists have proposed tube drills weighted with stones and used with abrasive sand, but we're not 100% certain. The moving of the largest stones. We've got good theories for how they moved the average 2.5-ton blocks, but those 80-ton granite beams in the King's Chamber, the 70-ton blocks used in Menkaur's pyramid, moving these would have required hundreds of workers and extremely robust sledges and ramps. It's possible, but the exact techniques remain somewhat mysterious. The precision of the casing stones. The casing stones fit together with joints so tight you can't fit paper between them. How did they achieve this level of precision in the fitting? Did they cut them to exact specifications at the quarry, or did they do final fitting on site? If on site, how did they test the fit of multi-ton stones? Some researchers suggest they might have used wooden templates or made fine adjustments using small copper tools, but we're not certain of the exact process. The internal ramps theory. Jean-Pierre Houdin's theory about internal ramps is compelling and would solve a lot of logistical problems, but we haven't definitively proven they exist. Non-invasive scanning has shown some anomalies consistent with ramps, but we'd need to actually look inside the pyramid to be sure, and nobody's keen on drilling holes in a World Heritage Site. These mysteries don't mean therefore aliens or therefore lost advanced civilization. They mean we're still learning. We're still figuring out the full extent of ancient Egyptian engineering capabilities. And honestly, that's exciting. The fact that a 4,500-year-old structure can still teach us things is pretty remarkable. Part 10, the logistics nightmare, or someone had to keep track of all this chaos. Let's talk about the sheer organizational nightmare of coordinating this project, because honestly, this might be even more impressive than the physical construction. You've got multiple quarries operating simultaneously. The local Giza limestone quarries are cutting blocks for the core. Tura, across the Nile, is cutting the fine white limestone for the casing. Aswan, 800 kilometers south, is cutting granite. All of these need to deliver stones in the right quantities, at the right times, to the construction site. Then you've got transportation. Stones from Tura need to be loaded onto boats, floated across the Nile during the inundation when water levels are high enough, then unloaded and transported to the construction site. The granite from Aswan needs to travel 800 kilometers down the Nile, a journey that would have taken weeks. At the construction site, you need to coordinate potentially 20,000 to 30,000 workers during peak periods. They all need to be fed, housed, supplied with tools, given medical care when injured, and organized into teams with specific tasks. Someone had to manage the food supply. We're talking about providing 4,000 plus pounds of meat daily, plus bread, beer, vegetables, and other supplies. The bakeries alone were massive operations. There's evidence of bread molds that could produce thousands of loaves. The breweries were churning out hundreds of gallons of beer. Tool maintenance was another massive undertaking. Copper tools wear down quickly when cutting stone. They need to be resharpened constantly and eventually replaced. The copper workshops at the workers' settlement were continuously producing and repairing tools. Then there's the actual construction coordination. You can't just have thousands of people randomly placing stones wherever they feel like it. There needs to be a plan, a sequence, a clear understanding of what gets built when. This required architects and engineers planning the overall structure and solving technical problems. Surveyors ensuring everything stayed level and aligned. Foremen managing individual work crews. Logistics coordinators managing the supply chain. Scribes keeping records of everything. Deliveries, work progress, resource allocation, medical staff, treating injuries, cooks and food preparers feeding everyone, tool makers keeping everyone supplied with working tools. The level of bureaucracy required for this project must have been extensive. Ancient Egypt was already a highly bureaucratic society. They kept detailed records of everything. The pyramid project would have generated mountains of paperwork, or papyrus work, I suppose. We've found some of these records. Papyri from the reign of Khufu include work logs, delivery records, and what appear to be progress reports. One fragment, known as the Diary of Mer, is a logbook kept by an official in charge of a team, transporting limestone from Tura to Giza. It's basically a 4,500-year-old spreadsheet documenting deliveries. The fact that we have this kind of documentation is remarkable. It shows that the pyramid wasn't built through chaos and brute force. It was built through meticulous planning, record keeping, and management. Think about the knowledge transfer required. This project took 20 years. Workers would have joined and left throughout that time. Some workers from the early years probably didn't live to see completion. New workers had to be trained. Knowledge had to be passed down. Techniques had to be documented and taught. This wasn't just physical labor. This was an organizational and intellectual achievement on a massive scale. Part 11, the religious significance, or why they actually did all this. We've talked a lot about how they built the pyramids, but we should spend some time on why, because understanding the religious and cultural context is crucial to understanding the sheer effort that went into these structures. To the ancient Egyptians, the pyramid wasn't just a tomb, it was a machine for resurrection. Egyptian religious beliefs about the afterlife were complex and evolved over time, but during the Old Kingdom, when the pyramids were built, there was a fundamental belief that the pharaoh was divine, either the living embodiment of the god Horus, or a son of Ra, the sun god. When the pharaoh died, he didn't just cease to exist, he transformed, joining the gods in the afterlife. But this transformation required the right conditions. The body needed to be preserved through mummification. The soul needed a place to reside, hence the elaborate tomb, and the pharaoh needed a way to ascend to the heavens, to join the gods. The pyramid shape itself was deeply symbolic. It's believed to represent the primordial mound that emerged from the waters of chaos at the creation of the world. It's also thought to represent a ramp or stairway to the heavens, allowing the pharaoh's soul to ascend to join Ra in his solar boat as he journeyed across the sky each day. The alignment of the pyramid with the cardinal directions wasn't just showing off engineering skills, it had religious significance. The sides faced the 4 cardinal points, connecting the structure to the cosmic order. The entrance faced north because certain important stars were in the northern sky, particularly the circumpolar stars that never set, symbolizing eternal life. Those mysterious shafts we talked about, they weren't just ventilation. The northern shaft from the king's chamber pointed toward the circumpolar stars, the indestructible stars that never died, never set below the horizon. The southern shaft pointed toward Orion's belt, which was associated with Osiris, the god of the afterlife. These weren't random, they were cosmic highways for the pharaoh's soul. The effort put into building these structures makes sense when you understand that the Egyptians believed the pharaoh's successful transition to the afterlife was essential for the continued prosperity of Egypt. The pharaoh wasn't just a political leader. He was the intermediary between the gods and humanity. His proper burial and successful resurrection ensured that Ma'at, cosmic order, truth, justice, would be maintained. So when thousands of workers spent decades building the Great Pyramid, they weren't just following orders. They were participating in a cosmic project that would ensure the continued favor of the gods and the prosperity of their civilization. That's why they wrote their team names on the blocks with pride. That's why they competed to work harder and faster. They believed they were doing something fundamentally important. The pyramid texts, religious inscriptions found in later pyramids, give us insight into the beliefs surrounding these structures. They contain spells, prayers, and instructions for the deceased pharaoh's journey through the afterlife. Lines like, O king, you are this great star, the companion of Orion, who traverses the sky with Orion, show the cosmic significance of these buildings. Understanding this religious context makes the achievement even more impressive. This wasn't just civil engineering. This was theology made manifest in stone. The precision, the alignments, the internal chambers, the shafts. All of it served both practical and spiritual purposes. Part 12. The construction errors. Or, yes, they made mistakes too. Here's something refreshing. Even the ancient Egyptian engineers made mistakes. The pyramids aren't perfect, and looking at where things went wrong actually helps us understand their construction methods. Let's start with the obvious one, the bent pyramid. We talked about this earlier, but it's worth emphasizing. They literally changed the angle halfway through construction because the original design was failing. The interior chambers show cracks that appeared during construction, scaring the engineers enough to change course. This wasn't a minor adjustment. It fundamentally changed the pyramid's appearance. But this failure is incredibly valuable to us. It shows, 1. The Egyptians were experimenting and pushing boundaries. 2. They could recognize structural problems and adapt. 3. They learned from mistakes. The Red Pyramid, built after, used the shallower angle from the start. In the Great Pyramid itself, there are several interesting anomalies. The king's chamber has cracks. The granite beams in the ceiling have several cracks that appeared either during construction or shortly after, from the immense weight above. This is why they built those relieving chambers. They knew the weight was tremendous and were trying to manage it. The cracks suggest they were right on the edge of what the stone could handle. The queen's chamber has a corbelled ceiling that seems unnecessary. If it was just a chamber, a flat ceiling would work. The corbelling suggests they were worried about structural integrity, possibly having learned lessons from earlier chambers that failed. The descending passage has slight irregularities. While incredibly straight for the most part, there are small variations that suggest the workers had to make adjustments as they went, possibly encountering harder or softer patches of bedrock. The passages and chambers aren't perfectly centered in the pyramid. The king's chamber is slightly offset from the pyramid's central axis. This might have been intentional for religious reasons, or it might have been a practical decision made during construction. There's also evidence of repairs and modifications made during construction. Some blocks show signs of being trimmed or adjusted to fit after they were placed. Some internal passages show evidence of being modified from their original plan. In some of the later pyramids, the construction quality noticeably declined. The Pyramid of Pepi II, for example, built a few centuries after Giza, looks impressive from the outside, but is poorly constructed internally. The core blocks are smaller and less carefully placed. It's actually partially collapsed today because the internal structure wasn't as robust. This decline tells us something important. The Giza pyramids represented a peak of both resources and expertise. Later pharaohs might have wanted pyramids, but they didn't have the same economic power or the same concentration of skilled workers that the 4th dynasty pharaohs commanded. Even the Great Pyramid's casing stones weren't all perfect. The few remaining casing stones show that while most were cut to incredible precision, some have slightly imperfect joints. They weren't aiming for absolute perfection. They were aiming for good enough, which happened to be extraordinarily good by any reasonable standard. These imperfections and errors are important because they humanize the achievement. These weren't magical constructions or alien technology. They were humans pushing the boundaries of what was possible with their technology, making mistakes, learning, adapting, and ultimately creating something extraordinary despite the errors. Part 13. The Grave Robbers, or the pyramid's greatest design flaw. Here's the sad irony of the pyramids. All that effort to create an eternal resting place for the pharaoh, and they were all robbed, probably within a few centuries of being sealed. The Great Pyramid had multiple security features. Granite plugs. After the pharaoh was entombed, Massive granite blocks stored in the Grand Gallery were released, sliding down to block the ascending passage. These weren't meant to be moved. They were too heavy and too perfectly wedged in place. Hidden passages. The entrance to the pyramid was deliberately obscured and sealed. If you didn't know where to look, you'd never find it. Dead-end passages. Some passages lead nowhere, potentially meant to confuse robbers. Portcullis systems. In some chambers, there were stone barriers that could be lowered to seal off passages. None of it worked. Grave robbers, probably within a few hundred years of the pyramid being sealed, managed to break in. They didn't go through the plugs. That would be nearly impossible. Instead, they tunneled through the softer limestone around the plugs, creating what's now called the Robber's Tunnel. This tunnel shows remarkable determination. These thieves cut through approximately 27 meters of solid limestone, probably using fire setting and copper chisels, the same techniques used to build the pyramid in the first place. They knew roughly where they were going. Someone probably had inside information about the pyramid's layout. When they reached the ascending passage, they navigated to the king's chamber and stripped it of everything valuable. The granite sarcophagus was too heavy to remove, so it remains there today, empty. Everything else? Gone. The queen's chamber, the grand gallery, the subterranean chamber, all were likely entered and looted. Any treasure, any grave goods, any decoration, all removed. This happened to virtually every pyramid. The only royal tomb from ancient Egypt that was found relatively intact was Tutankhamun's, and that was only because it was in the Valley of the Kings, hidden and relatively modest, and it was covered by rubble from later tomb construction. Even that tomb showed evidence of being entered by robbers shortly after it was sealed. Though they didn't manage to completely loot it, the pyramid builders knew this was a risk. Later burial practices moved away from pyramids, partly because they were such obvious targets. The pyramids literally advertised, "Pharaoh, buried here with lots of gold." The Valley of the Kings represented a different strategy, hidden tombs in a remote valley, with guards posted. But even that didn't work perfectly. Almost all those tombs were robbed too. The irony is that the pyramid's greatest success wasn't preservation, wasn't protecting their contents. It was protecting themselves. The structures are still there, still impressive, still doing their job of proclaiming the power and achievement of the pharaohs who built them. The treasure is gone, but the monument remains. In a weird way, maybe that's what they were really building all along. Not a treasure vault, but a testament. And if that was the goal, it worked spectacularly. Part 14, The Legacy, or How One Building Project Changed Everything. The influence of the pyramids on human culture and engineering cannot be overstated. Let's trace some of the ripple effects of this achievement. Immediate engineering impact. The techniques developed for pyramid construction influenced Egyptian building for the next 3,000 years. The understanding of leverage, ramps, and precise alignment was used in temple construction, tomb construction, and civic projects throughout Egyptian history. The organizational systems developed for managing massive labor projects became templates for other large-scale Egyptian endeavors. Mathematical and astronomical knowledge. The precision required for pyramid construction pushed forward Egyptian understanding of mathematics and astronomy. The surveying techniques, the calculations needed for planning, the astronomical observations required for alignment, all of this accumulated knowledge that was passed down and built upon. Architectural inspiration across millennia. Pyramid shapes appear in architecture throughout history and across cultures. Sometimes this is direct Egyptian influence, sometimes it's independent invention, but the Egyptian pyramids became the archetype. From Nubian pyramids, built by the Kingdom of Kush, to stepped pyramids in Mesoamerica, to modern pyramid-shaped buildings like the Luxor Hotel in Las Vegas or the Louvre Pyramid in Paris, the shape has endured. Proof of concept for human achievement. The pyramids demonstrated that humans could accomplish seemingly impossible tasks through organization, planning, and sustained effort. This isn't a small thing. These structures showed that collective human effort, properly organized and directed, could create permanent monuments that would outlast empires. tourism and wonder. The pyramids have been tourist attractions for thousands of years. Ancient Greek and Roman tourists visited them. Arab scholars studied them. European explorers obsessed over them. Today, millions of people visit them annually. They've been a source of wonder for longer than most civilizations have existed. Scientific study. The pyramids helped birth the field of Egyptology. Napoleon's expedition to Egypt in 1798 brought scholars who documented the pyramids in detail. The discovery and translation of the Rosetta Stone allowed us to read hieroglyphics, which unlocked understanding of Egyptian culture. The pyramids have been subjects of study for archaeologists, engineers, astronomers, and historians for over 2 centuries of modern scholarship. Cultural impact. The pyramids have appeared in countless books, movies, video games, and works of art. They've inspired mystery, conspiracy theories, spiritual movements, and scientific inquiry. They're one of the few ancient structures that everyone recognizes instantly. Engineering challenges to modern builders. Even today, engineers and architects look at the pyramids with respect and a bit of awe. Building a structure that will last 4,500 years is challenging, even with modern materials and techniques. The pyramids set a standard for permanence that few modern buildings meet. Symbol of human potential. Perhaps most importantly, the pyramids stand as proof that ancient peoples were just as intelligent, capable, and creative as we are today. They just had different tools. The persistent myth that ancient peoples couldn't have built these structures without help is not just wrong, it's disrespectful to human ingenuity. When you stand next to the Great Pyramid today, you're looking at a structure that has survived the entire rise and fall of ancient Egyptian civilization, the Persian, Greek, and Roman conquests of Egypt, the rise of Christianity and Islam, the Middle Ages, the Renaissance, the Industrial Revolution, 2 world wars, the Atomic Age, the Digital Revolution, and it's still there, still impressive, still teaching us things we didn't know. Part 15. Modern reconstruction attempts. Or can we still do this? Here's a fun question. Could we build a Great Pyramid today? The answer is yes, but you wouldn't want to. Several teams have attempted to reconstruct various aspects of pyramid construction using ancient techniques, and the results are fascinating. Mark Lehner's experiments, 1990s. Archaeologist Mark Lehner led a team that attempted to build a small pyramid about 6 meters tall, using ancient Egyptian techniques. They quarried blocks with copper tools and sand abrasives. They moved stones on sledges. They built the pyramid using ramps. Results: it worked, but it was incredibly labor-intensive. Even with modern knowledge of what they were trying to do, it took a team of workers weeks to build a tiny pyramid. The experiment confirmed that the methods we think the Egyptians used could work, but also emphasized just how much human effort went into the real pyramids. The Nova Pyramid, 1999. For a television documentary, a team attempted to build a small pyramid using ancient techniques in just 3 weeks. They had 44 workers and modern logistical support, vehicles to transport workers, modern food preparation, etc. Results: they managed to build a pyramid about 6 meters tall, but they had to cut corners. The blocks weren't as precisely fitted as original pyramid blocks. The alignment wasn't as accurate, and this was with a tiny fraction of the blocks needed for a real pyramid. The experiment drove home just how ambitious the original project was. Japanese research, 1978. A Japanese team attempted to build a small-scale pyramid using only ancient tools and methods. They struggled significantly with quarrying and moving the stones. They eventually abandoned pure ancient techniques and used some modern equipment to complete the project. Transport experiments. Various teams have experimented with moving large stones on sledges. The findings consistently support the wetted sand technique. In controlled experiments, teams have successfully moved multi-ton blocks using wooden sledges on wetted sand with teams of workers numbering in the dozens rather than hundreds. Stone cutting experiments. Researchers have successfully cut limestone and even granite using copper tools with sand abrasives, confirming this technique works. However, it's slow, far slower than modern diamond-tipped saws. This emphasizes the sheer amount of labor hours that went into preparing millions of blocks. Modern construction with modern tools. If we wanted to build a Great Pyramid today using modern construction equipment, cranes, trucks, power tools, we absolutely could. Engineers have calculated that with modern equipment, you could probably build a replica Great Pyramid in about 5 years with a few hundred workers. But here's the thing, nobody's going to spend the money to do it. The Great Pyramid contains about 2.3 million blocks. Even if each block costs just $1,000 to quarry, transport, and place, which is probably conservative, you're looking at over $2 billion just for the stone. Add in labor costs for modern skilled workers, equipment, engineering, permits, and oversight, and you're probably looking at a $5 to $10 billion project. For what? A really expensive monument to building a monument. The economic calculation that made sense in ancient Egypt. A divine king with absolute control over state resources, a workforce that could be mobilized during agricultural downtime, and religious beliefs that made the project cosmically important doesn't translate to the modern world. We could build a pyramid, we just wouldn't because it doesn't make economic or practical sense. Ancient Egypt didn't operate on modern cost-benefit analysis. They operated on a religious and cultural imperative that justified any amount of effort. That's kind of beautiful, actually. The pyramids exist because an entire civilization decided that some things are worth doing, even if they're impractical, expensive, and will take longer than any individual's lifetime to complete. Part 16, debunking the conspiracy theories. Or, let's put this nonsense to bed. All right, we need to address the elephant in the room that we've been dancing around. Conspiracy theories. Because despite overwhelming archaeological evidence, there are still people who insist the pyramids couldn't have been built by ancient Egyptians. Let's go through the main theories and why they're wrong. Theory number 1. Aliens built the pyramids. This one is almost too silly to address, but it's persistent, so here we go. The evidence for this usually includes the pyramids are too precise for ancient people. The stones are too heavy to move without modern technology. The astronomical alignments are too accurate. Why it's wrong. We've literally found the quarries, the tools, the workers' villages, the construction ramps, and the organizational papyri. The evidence for human construction is overwhelming. Every precision claim can be explained by techniques we know the Egyptians had. Patient work with simple tools can achieve remarkable precision. The idea that ancient people were too primitive to accomplish this is actually kind of racist. It assumes non-white ancient cultures couldn't have been sophisticated engineers. If aliens wanted to help ancient humans, why would they build pyramids? Why not share medical technology or advanced agriculture or literally anything more useful than a fancy tomb? Theory number 2. Lost advanced civilization / Atlantis did it. This usually claims that there was some highly advanced human civilization that predated ancient Egypt and either built the pyramids or taught the Egyptians how. Why it's wrong. We have a clear archaeological record of Egyptian civilization developing gradually over thousands of years. We can see the progression from simple mastaba tombs to step pyramids to true pyramids. The mistakes in pyramid construction, like the bent pyramid, show this was a learning process, not knowledge inherited from a more advanced civilization. There's no evidence of any advanced pre-Egyptian civilization in the area. None. We've excavated extensively. The advanced civilization would have needed to have left no trace except for teaching Egyptians to build pyramids, which is convenient. Theory number 3. They used sound/vibration/levitation to move the stones. This theory claims ancient Egyptians had access to some kind of sonic technology that could levitate heavy stones. Why it's wrong? There's no physical evidence for any such technology. We understand acoustics and sound waves pretty well. They don't work like this. We have clear evidence of more mundane methods: sledges, ramps, levers, and lots of human labor. If they had levitation technology, why do we find wear marks on sledges and ramp remains? Theory number 4. They couldn't have been built in 20 years. Some claim the timeline is impossible and must have taken much longer. Why it's wrong? The math actually works out. Placing one block every few minutes with a large workforce is feasible. We have organizational evidence showing this was run like a highly efficient operation. Modern construction projects with far fewer workers accomplish comparable or greater volumes of work. The Egyptians had advantages: unlimited labor during inundation season, no safety regulations, unfortunately, and cultural/religious motivation. Theory number 5. The blocks are too heavy for humans to move. This claims that 2.5-ton blocks, or the 80-ton granite beams, couldn't be moved by human power. Why it's wrong? Humans have moved far heavier things using simple machines. The Thunderstone in St. Petersburg weighs 1,500 tons and was moved in 1770 using capstans and wooden rollers. We've experimentally verified that sledges on wetted sand work for moving multi-ton blocks. The number of workers needed is large, but not impossibly so. A 2.5-ton block might need 20 to 30 workers. An 80-ton beam might need several hundred. Ancient peoples moved massive stones all over the world. Stonehenge, Easter Island, Baalbek, using various techniques, but always fundamentally relying on human labor and simple machines, the real reason. These theories persist. The pyramids are genuinely impressive. They look impossible. When modern people see them, it creates cognitive dissonance. How could ancient people do this? Rather than researching the actual answer, which involves patient work, sophisticated planning, and massive organized labor, it's psychologically easier to invent a mysterious explanation. Aliens, lost civilizations, magical technology. These theories are also, frankly, disrespectful to the thousands of Egyptian workers who spent their lives on these projects. Imagine dedicating decades of your life to creating something magnificent, and then thousands of years later, people insist you couldn't have done it and aliens must have helped. The truth is more inspiring than any conspiracy theory. Humans, working together with organization and purpose, can accomplish extraordinary things. Part 17. The Pyramid Complex, or its d'Siorge, wasn't just a pointy building. Here's something that might blow your mind. The pyramid itself was just one part of a much larger complex. When we talk about the Great Pyramid, we're actually talking about a massive architectural ensemble that covered a huge area of the Giza Plateau. Let's paint the full picture of what Khufu's pyramid complex actually looked like when it was completed, because this wasn't just build a pyramid and call it a day. This was an entire infrastructure dedicated to the pharaoh's cult and afterlife. The Valley Temple was located down near the Nile floodplain. This is where the pharaoh's body would have first arrived by boat during the funeral procession. It was a massive stone structure with columns, courtyards, and purification chambers. This was where the initial mummification rituals and purification ceremonies would have taken place. Sadly, Khufu's Valley Temple is now buried under the modern village of Nazlet El Saman, so we can't excavate it without demolishing people's homes. But we know it existed because we found similar temples at other pyramid sites. The causeway connected the Valley Temple to the Mortuary Temple. This wasn't just a path. It was a covered, elevated corridor about 800 meters long, rising from the valley to the plateau. The walls were decorated with reliefs, and the ceiling protected the passage from the elements. During the funeral procession, The pharaoh's body would have been transported along this causeway, probably accompanied by priests, mourners, and elaborate ceremonies. Imagine the scene: a procession moving slowly up this enclosed corridor, the sound of chanting echoing off the walls, the smell of incense, the solemnity of the occasion. This causeway was the path between the world of the living, down by the Nile, and the world of the eternal, up on the plateau with the pyramid. The mortuary temple, also called the Pyramid Temple, sat on the east side of the pyramid itself. This was a large, elaborate structure where daily offerings and rituals would be performed for the deceased pharaoh's ka, soul. After the pharaoh was entombed, priests would come here every day to make offerings of food, drink, and incense. This wasn't a one-time funeral. This was an ongoing cult that would continue for as long as the pharaoh's memory was honored. The mortuary temple had multiple chambers, courtyards, storage rooms for offerings, and probably living quarters for the priests who maintained the cult. We're talking about a substantial building complex in its own right. Unfortunately, much of Khufu's mortuary temple has been destroyed or buried, but we can reconstruct what it looked like based on better preserved examples from other pyramids. The satellite pyramid, sometimes called the cult pyramid, was a small pyramid located near the main pyramid. Its purpose is debated, but theories include it was a symbolic tomb for the pharaoh's ka. It was meant to house the canopic jars containing the pharaoh's organs, or it served some ritual function we don't fully understand. Khufu's satellite pyramid has been found, though it's largely ruined. The Queen's pyramids, yes, plural. On the east side of the Great Pyramid are 3 smaller pyramids, each about 20 meters tall. These are believed to have been for Khufu's wives, or possibly his mother. Each had its own small mortuary temple. These weren't afterthoughts. They were planned and integrated parts of the complex. The boat pits. Now this is fascinating. Around the pyramid, archaeologists have found 5 boat pits, long trenches carved into the bedrock designed to hold full-sized boats. 2 of these pits contained actual boats, disassembled and carefully buried. In 1954, archaeologist Kamal El-Malak discovered one of these boat pits on the south side of the pyramid. When they opened it, they found 1,224 pieces of cedar wood that, when reassembled, formed a complete boat, 43.6 meters long. This boat had clearly been used. It showed signs of wear from being in water. It's now displayed in the Giza Solar Boat Museum. Why boats? Multiple theories. Maybe they were solar boats, meant to carry the pharaoh across the sky with Ra. Maybe they were the boats that transported the pharaoh's body during the funeral. Maybe they were symbolic, ensuring the pharaoh had transportation in the afterlife. Probably some combination of all these reasons. The fact that they buried full-sized, functional boats that probably took years to build shows just how comprehensive the burial preparations were. Nothing was too much effort. The enclosure wall surrounded the entire pyramid complex. This wasn't just a boundary marker. It was a substantial limestone wall that separated the sacred space of the pyramid from the outside world. Inside this enclosure, you were in a space dedicated entirely to the pharaoh's eternal life. The workers' cemetery was located beyond the enclosure. Wall to the south. This is where the workers who built and maintained the pyramid complex were buried. The fact that they were buried near the pyramid they helped build, rather than in some distant location, speaks to the honor associated with this work. The priests' settlement housed the permanent staff who maintained the pyramid cult. These weren't just 1 or 2 priests. Maintaining the daily rituals, managing the offerings, keeping the complex clean and functional required a substantial permanent workforce. These priests would have lived in a community near the pyramid, dedicated to serving the deceased pharaoh's cult. So when you think about building the pyramid, you need to multiply that effort by a significant factor to account for all these associated structures. The pyramid itself was the centerpiece, the most visible element, but it was part of a much larger sacred landscape. And here's the kicker: Every pyramid had a complex like this. Khafre's pyramid, Menkaur's pyramid. They all had valley temples, causeways, mortuary temples, satellite pyramids, boat pits, and enclosure walls. The entire Giza Plateau was a massive necropolis, a city of the dead that rivaled the city of the living in its scope and ambition. Part 18, the social structure, or who exactly built this thing. We've talked about the workers in general terms, but let's get specific about who these people actually were and how Egyptian society organized itself to make this project possible. At the very top, the pharaoh Khufu wasn't just a political leader. He was considered divine or semi-divine. His word was literally law. When he decided, "I want a pyramid bigger than my dad's," that wasn't a suggestion or a proposal that needed approval. That was reality beginning to unfold. The resources of the entire nation could be mobilized for his projects. But, and this is important, pharaohs weren't tyrants ruling through fear alone. They governed through a complex system of reciprocal obligations. The pharaoh provided ma'at, order, justice, prosperity, and in return, the people provided labor and loyalty. It was a social contract, not just domination. The vizier and chief architect. Right below the pharaoh were his top administrators. For Khufu's pyramid, the vizier was Hemiunu, who also served as the chief architect. This wasn't someone who just drew up plans. This was someone who had to understand engineering, logistics, mathematics, astronomy, religious requirements, and project management at the highest level. Hemiunu would have been responsible for overall design and planning, resource allocation, coordinating with quarry managers, solving technical problems, ensuring the project stayed on schedule, managing the budget. Yes, even in ancient Egypt, someone had to worry about costs. We have a statue of Hemiunu, and he's depicted as a heavy-set man, which in ancient Egypt was actually a sign of prosperity and success. This was a man who ate well, who had authority, who was respected. His tomb near Khufu's pyramid is almost as elaborate as some pharaohs, which tells you how important his role was. The scribes never underestimate the importance of ancient Egyptian bureaucracy. Scribes were the record keepers, the accountants, the logistics coordinators. They tracked how many blocks were quarried each day, how many workers were on site, food rations distributed, tools issued and returned, progress on different sections, quality control issues, worker injuries and deaths. Literacy was rare in ancient Egypt. Maybe 1% of the population could read and write. Scribes were educated, respected, and essential. Without them, coordinating a project of this scale would have been impossible. We've found examples of their work. The Diary of Merer. I mentioned earlier, various papyri fragments with logistics information, and even some ostraca, pottery shards used as notepads, with quick notes about daily operations. The engineers and surveyors. These were the technical specialists who ensured everything was level, aligned, and structurally sound. They would have used tools like set squares for right angles, plumb bobs for vertical alignment, mercat, a sighting tool for astronomical observations, cubit rods for measurements, A-frames with plumb bobs for leveling. These weren't just tool users. They were specialists who understood geometry, trigonometry in their own way, and structural engineering. They had to calculate slopes, ensure stability, and solve problems on the fly when things didn't go according to plan. The skilled craftsmen. This tier included stone masons who could precisely cut and dress stone, carpenters who built sledges, ramps, and wooden tools, metal workers who produced and maintained copper tools, artists who would eventually decorate the mortuary temple and other structures, rope makers who produced the massive quantities of rope needed for hauling. These were people with years of training and experience. Becoming a skilled stone mason wasn't something you picked up in a few weeks. It required apprenticeship and practice. These workers were valuable, relatively well paid, by ancient standards, and probably had some job security. The foremen between the skilled craftsmen and the laborers were the foremen, the people who directly managed work crews. Each team of workers had a foreman who was responsible for their productivity, safety, such as it was, and coordination with other teams. The graffiti we find with team names? Those were probably organized by foremen who fostered team identity and competition. A good foreman could make a huge difference in productivity, and the evidence suggests foremen had significant authority and respect. The laborers. At the base of the pyramid, both literally and organizationally, were the thousands of laborers who did the heavy lifting. But even here there was differentiation. Permanent laborers who worked year-round, probably living in or near the workers' city. Seasonal workers who came during the inundation when farm work was impossible. Specialized haulers who became expert at moving stones efficiently. Support workers who weren't directly involved in construction but maintained the infrastructure. Cooks, water carriers, tool repairers, etc. These weren't slaves, but they weren't volunteers either, though some might have been. They were fulfilling their labor obligation to the state, and in return, they received food, shelter, medical care, and the knowledge that they were participating in something important. The priests don't forget that this was ultimately a religious project. Priests would have been involved in blessing the foundation, conducting rituals at various stages of construction, ensuring astronomical alignments were correct, planning the interior religious symbolism, preparing for the eventual funeral ceremonies. The line between religious and secular authority was blurry in ancient Egypt. Many high officials were also priests, and many priests had administrative roles. Women in the project. Here's something often overlooked. While the heavy construction labor was probably done by men, given the physical demands, women would have been essential to the support infrastructure. They would have been involved in food preparation and cooking, textile production. Workers needed clothes, beer brewing, possibly medical care, maintaining the workers' settlement. There's also evidence that some women held administrative positions. Egypt was unusual among ancient civilizations in that women could own property, conduct business, and hold positions of authority. While they probably weren't hauling stones, they were absolutely part of the larger project. Children. This might seem grim, but children would have been present too, not as workers. We have no evidence of child labor in pyramid construction, but as part of the families living in the workers' settlement. They would have grown up watching the pyramid rise, and some would eventually join the workforce themselves, carrying on their father's work. This generational aspect is important. The 20-year construction period means that some workers started as young men and finished as middle-aged veterans. Some died during construction and were buried in the workers' cemetery. Others lived to see the completed pyramid and probably took immense pride in pointing to it and saying, "I helped build that." Part 19, Daily Life on the Project, or what it actually felt like to build a pyramid. Let's get granular for a moment. What was it actually like to be a worker on the pyramid project? What did a typical day look like? Dawn. You wake up in the workers' dormitory as the sun rises. Ancient Egyptians didn't have alarm clocks, but they didn't need them. The sun was alarm enough, and there were probably foremen making sure everyone got up on time. Your bed is a simple mat on a raised mud brick platform, not comfortable by modern standards, but better than sleeping on the ground. You're sore, you're always sore, but that's just part of the job. Breakfast. You head to the communal eating area. Breakfast is bread, probably still warm from the bakeries that started work before dawn, and beer. The beer is thick, nutritious, and low alcohol, more like liquid food than what we think of as beer. Maybe some onions or dried fish if you're lucky. You eat with your team. These are people you've worked with for months or years. You know their families, their jokes, their strengths and weaknesses. You're probably friends with some of them, annoyed by others, but you're a unit. Morning work. The workday starts early, trying to get as much done as possible before the heat becomes unbearable. Your specific task depends on your role. If you're a quarry worker, you're cutting blocks from the limestone bedrock. You work in teams, some people using copper chisels to cut the trenches around blocks, others hammering in wooden wedges, still others managing the water that will swell the wedges and split the stone. It's repetitive, dusty work. The sound of copper hitting stone rings out constantly. You develop calluses on your calluses. You learn to read the stone, finding the natural weaknesses and bedding planes that make the work easier. If you're a hauler, your morning might involve loading a freshly cut block onto a sledge, then joining dozens of other workers in dragging it toward the pyramid. Someone walks ahead of the sledge, pouring water on the sand. You've learned that this makes a huge difference in how much effort it takes. You develop a rhythm: pull, step, pull, step. Sometimes someone starts a chant or song to coordinate the effort. When you're hauling a particularly heavy block, the foreman might call 4 more workers, and the rhythm changes as more people join. If you're working on placement, you're up on the pyramid itself, which means you started the day by climbing the ramp. The higher the pyramid gets, the longer this takes, and the more tired you are before you even start the real work. Once you're at your working level, you're maneuvering blocks into their final positions. This requires precision. The block needs to sit flush with its neighbors. You might use levers to shift it, wooden rollers to fine-tune the position, and constant checking with measuring tools to ensure it's level and properly aligned. Midday, as the sun reaches its peak and the heat becomes intense, work slows or stops entirely. This is the break period. You retreat to whatever shade you can find. The Egyptians weren't stupid. They knew working through the hottest part of the day was both dangerous and inefficient. Lunch is brought out. More bread, more beer, maybe some vegetables, and if you're lucky, some meat. The meat rations are one of the benefits of working on a royal project. You're eating better than you would back home on the farm. You rest, you joke with your crew, maybe you play a quick game of Senet, a popular Egyptian board game. Some workers catch a quick nap. The foremen use this time to check with the engineers and plan the afternoon's work. Afternoon work. As the sun starts to descend and the temperature becomes more bearable, work resumes. The afternoon might involve continuing the morning's tasks or shifting to different work. If blocks aren't arriving fast enough, some haulers might be reassigned to help at the quarry. If the placement crew is ahead of schedule, some might be moved to work on the ramp or other infrastructure. There's a constant flow of communication between different work areas. Messengers run back and forth. Foremen confer. Adjustments are made on the fly. Evening. As the sun nears the horizon, the day's work ends. You're exhausted. Depending on your specific job, you might have cut and moved several blocks. Quarry and hauling crews, on a good day, placed a dozen or so blocks in position. Placement crews surveyed and marked out the next day's work. Engineers and surveyors produced or repaired dozens of tools. Metal workers baked thousands of loaves of bread. Bakery workers. You head back to the workers' settlement, probably covered in limestone dust, sweat, and sand. There are washing facilities, basic but functional. You clean up as best you can. Dinner, the main meal of the day. Again, bread and beer are staples, but dinner includes more variety. Vegetables like onions, garlic, and lettuce. Legumes like lentils and chickpeas. And on good days, meat, beef, mutton, or fish. The meat is distributed based on your position and the day's productivity. Good work gets rewarded. There's an incentive structure even in the food distribution. Evening. After dinner there's actually some leisure time. This surprises modern people who imagine the workers were just worked to death, but the evidence shows they had downtime. You might play games with your friends. We've found game boards in the workers' settlement. Tell stories, or listen to others tell stories. Make music. We've found musical instruments. Visit the small shrines in the settlement to make offerings or pray. Work on small personal projects. Carving something, repairing your belongings. Just rest and talk. If you're married with family in the settlement, you spend time with them. If you're a seasonal worker, you might write a letter home, dictating it to a scribe if you can't write yourself. Night. As darkness falls, most people head to bed. There's no artificial lighting beyond oil lamps, and those are expensive. The rhythm of life follows the sun. You lie down on your mat, your muscles aching, your hands rough from the day's work, but you're well fed, you have shelter, and tomorrow you'll continue working on something unprecedented in human history. You fall asleep to the sounds of thousands of other workers doing the same. All of you part of a machine that is quite literally moving mountains. Rest days. The Egyptians did have rest days, though probably not a regular weekly schedule like our weekends. Major religious festivals meant breaks from work. The hottest days in summer might mean reduced work or rest days. Injuries or illness meant time off to recover. During the inundation season, when seasonal workers left to return to their flooded fields, the permanent workforce would probably have had a somewhat lighter schedule, focusing on maintenance, tool production, and planning for when the seasonal workers returned. Part 20. The economics, or how do you pay for building a mountain? Let's talk money. Or rather, since ancient Egypt didn't use coined money, that would come later. Let's talk about the economics of how you fund a CEDAR project of this magnitude. The resource base. Ancient Egypt was rich, not in gold or silver, though they had some of that, but in the fundamentals, agricultural surplus. The Nile flood was like clockwork. Every year, the river would flood, depositing nutrient-rich silt on the fields, making Egyptian agriculture incredibly productive. Egyptian farmers could produce more food than they needed for their own families, and that surplus was the foundation of Egyptian civilization. The state, meaning the pharaoh, controlled this surplus through a system of taxation. Taxes weren't paid in money. They were paid in grain, barley, and emmer wheat mostly. Other agricultural products, cattle and other livestock, labor, the corvée system we discussed. This surplus was stored in massive state granaries. The vizier's office managed these granaries and the distribution of their contents. It was essentially a centrally planned economy, at least for major state projects, feeding the workers. The single biggest ongoing expense was food. We're talking about feeding 20,000 to 30,000 workers during peak seasons. That's a lot of food. Estimates suggest the pyramid workforce consumed approximately 4,000 plus pounds of meat per day, 15,000 plus loaves of bread per day, thousands of gallons of beer per day, substantial quantities of fish, vegetables, and other foods. Where did this come from? The state granaries and state-controlled herds. The agricultural surplus from across Egypt was redirected to the pyramid project. To put this in perspective, feeding the pyramid workers for 20 years probably consumed more resources than running the government for the same period. This was a massive investment of national wealth. Labor costs. In a modern economy, labor is usually the biggest cost of a major construction project. In ancient Egypt, it's more complicated. The seasonal workers were fulfilling their tax obligation, so in a sense, they weren't paid. They were doing their civic duty, like jury duty or military service today, but they were fed, housed, and clothed, which represents a real cost to the state. The permanent workers and skilled craftsmen probably received regular salaries paid in. Grain rations, the basic currency of ancient Egypt. Beer rations, meat rations, clothing, housing, maybe some luxury items for the more skilled positions. A skilled craftsman might receive the equivalent of several times what a seasonal laborer's rations were worth, reflecting their greater value to the project. Material costs. Limestone. Free. Well, sort of. The local limestone was quarried from the Giza Plateau itself. The cost was just the labor to extract it. Tura limestone for casing. More expensive because it had to be transported across the Nile, but still relatively local. granite from Aswan, expensive. Not only is granite harder to quarry than limestone, but transporting it 800 kilometers down the Nile was a major undertaking. Each 80-ton granite beam represented probably weeks or months of effort by specialized crews. Copper for tools. Copper had to be imported from Sinai or traded for. This was a real cost. The amount of copper tools needed for the project was substantial. They wore down quickly and needed constant replacement. Wood for sledges, ramps, and tools. Egypt isn't heavily forested, so quality wood, cedar from Lebanon for example, had to be imported. This was expensive. Rope, needed in massive quantities. Rope wears out, breaks, needs constant replacement. Producing rope required dedicated workers and raw materials, plant fibers. Opportunity costs. Here's something modern economists would focus on. Opportunity cost. Every worker on the pyramid project was a worker, not doing something else. They weren't. Growing more food, building irrigation systems, creating trade goods, building other infrastructure, fighting in the army. Though Egypt was relatively peaceful during this period, the pyramid project represented a massive opportunity cost. The nation was essentially saying, the pharaoh's afterlife and the glory of Egypt are more important than any other use of these resources. This was sustainable because 1. Egypt was rich enough to afford it. 2. The seasonal labor system meant farm work still got done. 3. The project was viewed as religiously and politically essential. 4. The wealth and stability of Egypt during the Fourth Dynasty were at a peak comparative economics. To put the cost in modern terms is almost impossible because the economies are so different. But let's try. If we calculate based on labor hours, admittedly very rough, you're looking at something like 100,000 workers, averaging maybe 100 days per year for 20 years. That's 200 million person days of labor. At modern labor costs, even at minimum wage, that's tens of billions of dollars just in labor. Add materials, tools, infrastructure, and overhead, and you're probably looking at a project that, in modern terms, would cost $50 to $100 billion or more. As a percentage of GDP, it's hard to calculate for an ancient economy, but rough estimates suggest the Great Pyramid might have consumed 10 to 20% of Egypt's economic output for those 20 years. For comparison, the Apollo Moon program cost about 2.5% of US GDP spread over a decade. The Pyramid Project was probably a bigger economic commitment relative to the size of the economy. Was it worth it from a modern economic perspective? No. The pyramid produced nothing. It didn't improve agriculture, didn't enhance trade, didn't strengthen defenses. It was pure consumption, economically speaking. But economics isn't everything. The pyramid demonstrated the power and organization of the Egyptian state, fulfilled crucial religious obligations, provided employment during the off-season when workers would have been idle anyway, created a sense of national purpose and achievement, produced a monument that would advertise Egyptian capability for thousands of years. From the Egyptian perspective, asking, was it worth it economically, would be like asking, is art worth it economically? The question misses the point. The pyramid was a statement. It said, we can do this. We have the resources, the organization, the skill, and the will to build something that will outlast empires. And 4,500 years later, we're still talking about it. So, mission accomplished? Part 21. The decline of pyramid building. Or, why did they stop? After the magnificent pyramids of the Fourth Dynasty, Khufu, Khafre, Menkaure, pyramid construction continued for centuries, but never again at the same scale or quality. Why? Economic exhaustion. Building the Giza pyramids may have stretched Egypt's economy to its limits. The massive resources diverted to these projects were sustainable during the prosperous Fourth Dynasty, but that level of expenditure couldn't continue indefinitely. By the 5th and 6th dynasties, pyramids got smaller. They were still built, but on a more modest scale. The Pyramid of Unas, last pharaoh of the 5th dynasty stands only about 43 meters tall, compared to Khufu's 146 meters. That's less than a third of the height, which translates to a tiny fraction of the volume and material. Political changes. The absolute power of the pharaoh began to erode. Provincial governors, nomarchs, became more powerful and independent. The centralized control that allowed a pharaoh to command the entire nation's resources for his tomb became harder to maintain. The first intermediate period, roughly 2181 to 2055 BCE, saw Egypt fragment into competing regions. When you're fighting civil wars and dealing with weak central authority, building massive pyramids isn't a priority. Religious evolution. Egyptian religious beliefs evolved. The pyramid texts, religious inscriptions found in later 5th and 6th dynasty pyramids, show a shift in emphasis. The focus moved somewhat away from the pyramid as a physical resurrection machine toward the texts and rituals themselves as the key to afterlife success. During the Middle Kingdom, 2055 to 1650 BCE, pyramids were still built, but they were different. They often had mud brick cores with stone casing, making them cheaper to build but less durable. Many have collapsed over the millennia, while the solid stone Old Kingdom pyramids endure. Practical lessons. The Egyptians had learned that pyramids, for all their grandeur, weren't actually good at protecting the pharaoh's burial. They all got robbed. The massive, obvious structure that screamed Pharaoh, buried here with treasure, turned out to be a strategic mistake from a security standpoint. The New Kingdom, 1550 to 1077 BCE, saw a complete change in strategy. Pharaohs were buried in hidden tombs in the Valley of the Kings, with no massive superstructure advertising their location. Did this work better? Mostly no. Almost all those tombs got robbed, too, but it at least showed they'd learned something. The last pyramids. Pyramid building didn't completely stop. Small pyramids continued to be built. During the Middle Kingdom, during the Nubian 25th dynasty, around 700 BCE, in Nubia itself, modern Sudan, where the Kingdom of Kush built their own pyramids, inspired by Egyptian tradition but distinct in style. But these were echoes of the Great Pyramid Age, not continuations of it. The techniques, the scale, the ambition, these never returned to 4th dynasty levels. The Great Pyramid of Khufu remained the tallest structure in the world until 1311 CE, when Lincoln Cathedral's spire finally exceeded it. Think about that. A structure built in 2550 BCE held a record for 3,861 years. No pyramid built after the 4th dynasty even came close to challenging that record. The Pyramid Age peaked early and never returned. Part 22. The survivors, or the people who saw it all. Let's talk about something we haven't really touched on. What happened to the workers after the pyramid was finished? Imagine you're a worker who started on the project as a young man of 20. You've just spent the last 20 years of your life hauling stones, cutting blocks, and building something unprecedented. You're now 40 years old, middle-aged by ancient standards, where life expectancy was maybe 50 to 60 if you were lucky, and didn't die from injury or disease. The pyramid is complete. The pharaoh Khufu has died and been entombed. The funeral ceremonies are finished. The capstone gleams golden in the sun. The mortuary temple is functioning, with priests making daily offerings. And now, what for the permanent workers? Some workers transitioned into maintaining the pyramid complex. The mortuary cult needed staff, priests to perform daily rituals, guards to protect the complex. A lot of good that did, but they tried. Maintenance workers to keep the causeway clean, the temples functional, and the complex presentable. Administrators to manage the offerings and the endowments that funded the cult. These jobs would continue for generations as long as the pharaoh's cult remained active and funded. Some workers' families might have served the pyramid complex for centuries, a hereditary responsibility and privilege. For the seasonal workers, they went back to their farms, back to their villages, back to their regular lives, but they carried something with them, the knowledge that they'd participated in something historic. Imagine being that guy in your village. Oh yeah, I helped build the Great Pyramid, spent 5 inundation seasons hauling stones. My team set the record for most blocks moved in a single day in year 14. You'd be telling that story for the rest of your life. Your kids would tell it. Your grandkids would tell it. For generations, families would trace their lineage back to great-great-grandfather who built the pyramid. For the skilled craftsmen, the truly skilled workers, the master stone masons, the experienced surveyors, the talented engineers, they had marketable skills. There were always construction projects in ancient Egypt, temples, palaces, tombs for nobles, civic buildings. Some probably went on to work on Khafre's pyramid, which was started soon after. Others might have hired out to provincial governors for local projects. The best might have been retained by the royal court for future pharaonic projects. The knowledge they gained building the Great Pyramid wasn't wasted. It was passed down, refined, and applied to other projects. This is how Egyptian construction techniques evolved and improved over centuries. For those who didn't make it, let's not romanticize this too much. Construction was dangerous. People died. We found the workers' cemetery, and it contains burials of men who died from accidents, crushed by falling stones, falls from heights, injuries that became infected, no, antibiotics in ancient Egypt, overwork and exhaustion, heat stroke, heart attacks, diseases. Working in quarries creates dust that damages lungs. The cemetery shows that when workers died, they were buried with some honor. They weren't just thrown in a pit. They had proper burials, though obviously not as elaborate as nobles or royalty. Their service was recognized even in death. Some workers were crippled by injuries, but survived, as we discussed earlier. That worker with the amputated leg, for example. What happened to them? Hopefully, they were supported by their families or given easier work. Ancient Egyptian society did have some concept of social responsibility, though obviously nothing like modern social safety nets. The living memory. For perhaps 50 to 70 years after the pyramid's completion, there would have been living people who remembered its construction. Old men and women who could say, I was there when they placed the capstone, or I helped cut the stones for the king's chamber. Then those people died, and the pyramid's construction passed from living memory into legend. Stories were told, but they became less detailed, more mythologized. Details were forgotten or distorted. By the time Herodotus visited Egypt around 450 BCE, more than 2,000 years after the pyramid was built, the Egyptian priests he talked to were passing on stories that had been handed down for dozens of generations. Some of what they told him was probably accurate. Some was definitely garbled or invented. This is why archaeology is so important. The physical evidence, the quarries, the tool marks, the worker settlements, the organizational papyri, tells us what actually happened, not what people remembered or imagined happened. The pyramid's second life. For the permanent staff and their descendants, the pyramid wasn't history. It was their present. They maintained the cult, made the offerings, and kept the complex functioning. This continued for centuries. Even after the Old Kingdom collapsed, and Egypt went through tumultuous periods, the Giza pyramids remained important. They were too significant, too impressive, too central to Egyptian identity to be forgotten. Later pharaohs would make offerings at the old pyramids. The 18th dynasty, Pharaoh Thutmose IV, who reigned around 1400 BCE, more than 1,000 years after Khufu, recorded that he cleared sand from the Sphinx and made offerings at the Giza complex. By his time, the pyramids were already ancient, but they were still revered. Even the Greeks and Romans, when they conquered Egypt, recognized the pyramids as something special. They became tourist attractions, even in antiquity. Wealthy Greeks and Romans would visit, just as tourists do today. The pyramid survived its builders, their children, their civilization, their language, their religion, and their entire way of life. It outlasted everything except the desert itself. And it's still there, still teaching us, still inspiring us, still proving what humans can accomplish. Part 23, What We're Still Learning, or The Pyramid Isn't Done Teaching Us. You might think that after thousands of years of study, we'd know everything there is to know about the pyramids. You'd be wrong. Recent discoveries, 2000s to 2020. In 2013, archaeologists discovered a papyrus, the Diary of Merer, at Wadi al-Jarf on the Red Sea coast. This 4,500-year-old document is the oldest papyrus ever found, and it's literally a logbook kept by an official named Merer, who was in charge of a team transporting limestone from Tura to Giza during the later years of Khufu's reign. This is huge because it's direct contemporary evidence from someone actually working on the project. It's not a story told centuries later. It's primary source documentation from the time. The diary mentions the noble Ankaf, probably Prince Ankaf, Khufu's half-brother who was an overseer of construction. It describes delivering stones to the horizon of Khufu, one of the names for the Great Pyramid. It gives us concrete numbers and details about the logistics of the operation. Finding this was like finding a construction foreman's daily log from a skyscraper built in 1925. It's that rare and that valuable. Technology revealing secrets. Modern technology is allowing us to study the pyramids in ways that weren't possible even 20 years ago. Cosmic ray muon tomography. In 2017, scientists used muon detectors. Muons are particles created when cosmic rays hit Earth's atmosphere to essentially X-ray the Great Pyramid. They discovered a previously unknown void about 30 meters long above the Grand Gallery. What is this void? We don't know yet. It might be a hidden chamber. It might be a structural feature. It might be a deliberate gap in the construction. We haven't opened it or explored it directly. Again, nobody wants to drill holes in a World Heritage Site without a very good reason. But the fact that we're still discovering new features in the Great Pyramid in the 21st century is mind-blowing. LiDAR and 3D scanning. Modern scanning technology has created incredibly detailed 3D models of the pyramids, allowing researchers to analyze their geometry and construction with unprecedented precision. These scans have revealed subtle details about how the blocks were fitted together, how the structure has shifted over millennia, and how the internal chambers relate to the overall design. Chemical analysis. Analysis of tool marks and residues on stones has given us insights into exactly what techniques were used. By studying the microscopic traces left by copper tools, abrasives, and various construction processes, we can reconstruct the specific methods employed by ancient workers. Satellite imagery and ground-penetrating radar. These technologies have revealed previously unknown structures around the pyramids, additional causeways, workers, settlements, and possibly quarry sites. The fuller picture of the pyramid complex continues to emerge. Ongoing debates. Even with all this technology and research, there are still active debates among Egyptologists. The internal ramps theory. Jean-Pierre Houdin's theory about internal ramps is still being investigated. The muon scans provide some support, but definitive proof would require invasive investigation that no one is willing to do yet. The exact construction timeline. While we think it took about 20 years, the exact sequence of construction, what was built when, is still debated. Different researchers have different theories about whether the internal chambers were built first and the pyramid built around them, or whether they were built as the pyramid rose. The purpose of various features. Those mysterious shafts from the Queen's chamber that don't go all the way through. We're still not 100% certain what they were for. the small door discovered by the robot camera. What's behind that second blocking stone? Why is it there? The original appearance. We know the pyramid was covered in white limestone casing stones with a golden capstone, but exactly how smooth was the surface? How reflective? Some researchers think it might have been so polished it acted like a mirror. Others think it was smooth, but not mirror-like. What we'll never know. Some things are probably lost to history forever. The exact number of workers who participated. The total death toll from accidents and injuries. The names of most of the workers. We have a few from graffiti, but most are anonymous. Many of the religious rituals and beliefs that motivated the construction. The exact contents of Khufu's burial, all removed by grave robbers millennia ago. The full extent of the pyramid complex. Some parts are now under modern buildings, but that's okay. The fact that the pyramids still have secrets, after 4,500 years of human curiosity, is part of their appeal. They remind us that the past isn't fully knowable, that mystery is part of history, and that there's always more to learn. The future of pyramid research. Technology will continue to reveal new information. AI analysis of construction patterns, advanced materials science, better non-invasive scanning techniques. All of these will contribute to our understanding. There are probably discoveries waiting to be made in the sands around Giza. There are probably features of the pyramids we haven't noticed yet. There are probably connections and patterns we haven't seen. The pyramids have been teaching us for 4,500 years. They're not done yet. And honestly, that's beautiful. A structure built by people who have been dead for over 4 millennia continues to educate, inspire, and challenge us. It continues to reveal its secrets slowly, on its own timeline. The pyramid builders built something that would outlast them. They succeeded beyond their wildest dreams. Ultimate final thoughts. Your pyramid. We've traveled together through 30,000 words, exploring how the pyramids were actually built. We've covered the engineering, the mathematics, the logistics, the social organization, the economics, the religion, the daily life, the mistakes, the mysteries, and the legacy. But here's the thing I really want you to take away from this. The pyramid builders were just people like you. They weren't superhuman. They didn't have magical powers. They didn't have help from aliens or lost civilizations. They had problems to solve, tools at their disposal, knowledge accumulated over generations, the ability to plan and organize, the willingness to work hard over a long period, the belief that what they were doing mattered. That's it. That's the secret formula. And here's the thing. You have all of those things too. You have problems to solve. Probably not, how do I move a 2.5-ton limestone block, but your own challenges. You have tools at your disposal, probably better tools than copper chisels and wooden sledges, if we're being honest. You have knowledge. The accumulated wisdom of all of human history is at your fingertips via the internet. You have the ability to plan and organize. You're reading this 30,000-word script, so clearly you can handle complex information. You have the potential to work hard over a long period. Consistency over time is how great things get built. And hopefully, you believe that what you're doing matters, or at least you can find something that matters enough to dedicate effort to. So what's your pyramid? What are you building that will outlast you? What are you creating that will matter after you're gone? What are you working on that's bigger than yourself? It doesn't have to be a literal pyramid. It doesn't have to be a massive monument. But it should be something. Maybe it's raising kids who will make the world better. Maybe it's building a business that serves people. Maybe it's creating art that moves people. Maybe it's solving a problem that makes life easier for others. Maybe it's just being consistently kind and making the world slightly better by being in it. The pyramid builders teach us that humans are capable of extraordinary things, but they also teach us something else. Those extraordinary things are built slowly, patiently, one stone at a time. They didn't build the Great Pyramid in a day. They built it over 20 years, one block at a time. Some days probably felt like no progress was being made. Some days were setbacks. Some days were triumphs. But they kept going. And eventually they built something that's still standing, 4,500 years later. Whatever you're building, keep going. One block at a time, the pyramid builders believe in you. So do I. Now go build something amazing. Final conclusion, the message. Across millennia, we've spent over 28,000 words together, walking through every aspect of how the pyramids were built, from the bedrock foundation to the golden capstone, from the quarries to the workers' settlement, from the engineering to the economics, from the religious significance to the human cost. And here's what it all comes down to. The pyramids are a message from the past, and that message is this: humans are capable of extraordinary things when we work together toward a common purpose. Not aliens, not lost civilizations, not mysterious technologies, just us, humans. Using copper tools, wooden sledges, our brains, our muscles, and most importantly, our ability to organize and cooperate on a massive scale. When you look at the Great Pyramid, you're looking at 2,300,000 stones, each one cut, moved, and placed by human hands. Over 20 years of sustained effort, involving tens of thousands of people, coordinated with Bronze Age technology, resulting in something so well built, it's still standing 4,500 years later. That's not a story about what ancient people couldn't do. That's a story about what humans can do. Every conspiracy theory about the pyramids, aliens, lost civilizations, magical technology, ultimately rests on the same assumption, that regular humans couldn't have done this. And that assumption is not just wrong, it's insulting to human capability. The truth is so much more inspiring. Given enough time, enough organization, enough motivation, and enough cooperation, humans can move mountains, literally. The Egyptians proved it. So the next time you're facing something that seems impossible, remember the pyramid builders. They didn't have advanced technology. They didn't have shortcuts. They had a clear goal, good planning, cooperation, persistence, and the belief that what they were doing mattered. That was enough to create a wonder of the world that's still standing 4,500 years later. If that's not inspiring, I don't know what is. Now get out there and build your own metaphorical pyramid. You've got the same brain and the same capabilities as the people who built the real ones. They just had different tools. What's your excuse? Conclusion: what the pyramids really teach us. So here we are, at the end of our journey through 4,500 years of history, engineering, and human achievement. You've stood in the scorching sun with ancient Egyptian workers. You've watched them quarry, transport, and place millions of tons of stone. You've seen the planning, the mathematics, the organization, and yes, the mistakes. What can we take away from all this? First, human beings have always been capable of extraordinary things. The people who built the pyramids weren't primitive. They were sophisticated engineers, mathematicians, and project managers working with the best technology available to them. They solved problems that would challenge us today. Second, great achievements require organization and cooperation. One person can't build a pyramid. 100 people can't build a pyramid. But tens of thousands of people working together with clear goals and good organization can build something that lasts for millennia. Third, cultural and religious motivation matters. The pyramids exist because an entire society believed they were worth building. That kind of collective purpose, that willingness to work on something that won't be finished in your lifetime, is rare and powerful. Fourth, the best way to be remembered is to build something worth remembering. Khufu's mummy is gone. His treasure is gone. His empire is gone. But his pyramid, still there, still impressive, still teaching us things 4,500 years later. That's immortality. Fifth, simple tools, properly applied, can accomplish remarkable things. The Egyptians didn't need advanced technology. They needed copper tools, wooden sledges, careful planning, and patient execution. Sometimes the simplest solution is the right one. Sixth, precision and quality matter. The pyramids could have been built good enough. They could have been rougher, less precise, less carefully aligned. But the Egyptians went for excellence, and that's why these structures have survived when other ancient buildings have crumbled. Seventh, we should respect our ancestors. The conspiracy theories about pyramids all rest on the assumption that ancient people couldn't have been smart enough or capable enough to build them. This is wrong and insulting. Our ancestors were just as intelligent as we are. They just had different knowledge and different tools. When you look at the Great Pyramid today, whether in person or in photos, you're looking at a message sent across 4,500 years. It's not a message in words, it's a message in stone, and that message is simple. We were here. We were capable. We built something that would outlast our civilization, our language, even our gods. We created something permanent in a temporary world. And you know what? They succeeded. The ancient Egyptian civilization is gone. The Old Kingdom fell thousands of years ago. The Middle Kingdom rose and fell. The New Kingdom rose and fell. Egypt was conquered by Persians, Greeks, Romans, Arabs. The religion changed. The language changed. The culture transformed almost beyond recognition. But the pyramids? They're still there, standing on the Giza Plateau, looking out over what was once the greatest city in the world. These massive monuments to human ambition and capability continue to inspire wonder, respect, and maybe a little bit of healthy humility. Because if Bronze Age humans with copper tools and wooden sledges could build something this magnificent, this precise, this enduring, what's our excuse? What are we building that will still matter in 4,500 years? What message are we sending to the future? The pyramids challenge us not just to understand how they were built, but to aspire to create things of lasting value ourselves, not necessarily giant stone monuments. We have different challenges and different opportunities than ancient Egypt did, but the principle remains. With planning, cooperation, dedication, and the willingness to work on something bigger than ourselves, we can create things that matter, things that last, things that future generations will look at and say, wow, they actually did that. The ancient Egyptians figured out how to build mountains, not with magic, not with aliens, with mathematics, engineering, organization, and thousands of people working together toward a common goal. If that's not inspiring, I don't know what is. So the next time someone tells you the pyramids couldn't have been built by humans, you can smile and tell them the truth. Not only were they built by humans, they were built by humans who would probably look at our modern inability to build anything that lasts more than a few decades and wonder what happened to us. The pyramids aren't mysteries. They're not impossibilities. They're not evidence of aliens or lost civilizations. They're proof of what humans can accomplish when we decide that something is worth doing, and then we actually do it. And honestly, that's so much cooler than any conspiracy theory.